This presentation discusses and demonstrates the impact of the battery state of charge on the hazards associated with lithium-ion batteries. FM Property Loss Prevention Data Sheet 7-112 Lithium-ion Battery Manufacturing and Storage is the first of its kind loss prevention data sheet providing fire protection guidance for the hazards associated with lithium-ion battery manufacturing and storage. There are several defined thresholds for lithium-ion cells and batteries with regards to transportation and storage regulations, as well as fire protection for completed cells. First, testing has shown that lithium-ion cells and batteries with a state of charge greater than 60% generate significantly more flammable gases, and when ignited results in much higher heat release rates. For lithium-ion cells and batteries with a state of charge in the 30 to 60% range, there can be an increased fire hazard, depending upon the configuration of storage arrangements, such as solid pile, rack, automatic storage and retrieval systems, etc. Finally, a state of charge of less than 30% results in a minimal additional hazard due to the lithium-ion battery and is currently a common threshold for transportation of cells via ocean and airlines. The following side-by-side test videos demonstrate thermal abuse of 3 test arrangements, which are identical except for the different states of charge of 30%, 50%, and 100%. A propane torch ignition source is located approximately 12 inches, 20 centimeters, away from the cell. The timing of the tests has been synchronized so that the displays are concurrent. In the left video, with the cell at 100% state of charge, the gases ignite almost immediately upon contact with the pilot flame, and intense flames persist throughout the thermal runaway event until the fuel is eventually spent. This is because the gases released are more flammable and there is more heat produced from the chemical reaction of a thermal runaway over the same period of time when compared to the lower states of charge. In the center video, with the cell at 50% state of charge, you can see the vented gases have less momentum and do not immediately ignite like the 100% state of charge test. However, the gases do eventually ignite and sustain a flame until the fuel is spent. The video on the right shows a cell at 30% state of charge that has been driven into thermal runaway. As you can see, the cell has vented a lot of gas and vapors are being released, but even with a flame present, the released gases are not igniting. Identical lithium-ion cells abused at 3 different states of charge produced 3 very different fire scenarios. In conclusion, the previous test videos help understand the impact of state of charge on the fire hazard of lithium-ion cells and batteries. In general, the higher the state of charge, the greater the hazard. The state of charge is a primary consideration in determining the level of fire protection needed for storage of lithium-ion batteries. For more information on protection of lithium-ion battery manufacturing and storage, access FM Loss Prevention Data Sheet 7112, Lithium-ion Battery Manufacturing and Storage, on the resources page at fm.com.